Yeah, I'm fixing that. Sorry. Um, I think I just did. Uh, did I? No. Is it? Let me try that again. Did I? No. I think it's the right link now. Yeah. See if people catch on. This is it. All right, I think people are finding it now. It's been a rough couple weeks. We'll get through it. All right. Today's lesson is not difficult, so that's good. Honestly, it's pretty much what we did yesterday anyways. So I'm going to go ahead and try to get started here. What are we doing today? Writing rules for linear equations. So rules for linear equations. So what you're going to see is writing rules for linear equations. In this case, we want to write the function. So your rule, or whatever you're writing, should look like f of x equals something. And it's going to have the rule, and due to the fact that it's a linear equation, it's going to fit slope-intercept form, so it's going to equal mx plus b. So your rule should look like this. This is what we should look like. And depending on what it gives you, there's other ways to do it. So you can represent this function as a graph. So it might give you a graph and then ask you what's the rule. It might give you a table, right? It might have an XY table, right? I guess I could draw like a little graph and be like, hey, what's the rule for this line? It might give you an XY table and have you write the rule from that. It might give you a word problem and ask you to write the rule from that. So we're going to have different scenarios that you're going to get, and you're going to have to take each of these scenarios and translate it to this form. And the easiest one, I think, was the graph from yesterday. So we kind of did graphing yesterday, and we kind of did tables yesterday. Word problems are going to just take some practice, but I mean, that's with all word problems. You're going to have to sit there and read it and make sure you understand what's going on. So keep that in mind. We'll probably end up doing those last. So let's look at finding rules for graphs. And we're actually going to go backwards from your homework. So your homework was page, was it 420? The 1 through 3 are done with word problems. 4 through 6 are from tables. And 7 through 8, 7 and 8 are from the graph. So let's work our way backwards here, I guess, because I think graph is probably the easiest to do. Table is probably the second easiest, and word problem is just going to take some practice. It's not hard, it just takes some practice. So that's our goal for today. We're going to look at a graph, see if you can give me the rule for the graph, the function for the graph. Look at a table, see if you can give me the rule for the table, the function for the table. And look at a word problem, see if you can pull out the function from it. And again, everything is going to follow what this looks like here. So what we're going to do is we're going to keep this around. That is what we want to keep around. So let's go ahead and just walk through some examples on how to do things. Let's get a new one of these. And again, we're keeping this around. So let's go ahead and get a graph. And I was fiddling too much with the embedder, so I think I fixed the link. It should be linking now. But again, we're just going to be looking at writing rules from things. So let's get a coordinate plane here, and let's just make a graph. We'll just make a random graph. That one's not going to work. That one's not going to work. Where's the one that works? This one will work. Copy image. Over here, let's paste our graph. And we're just going to make a random graph of a line. I don't know what it's going to be. Let's just pick a couple points that make sense. There's a nice point there, and there's a nice point. Let's make it so we have a nice y-intercept. That looks like a nice y-intercept. Just so we can actually read what's going on. So let's say we have this graph, and we want to find the rule for this graph. So we want to make it look like y equals mx plus b. So what we need to do is we need to find m, and we need to find b. And we did this kind of yesterday too. Keeping in mind m is your slope, b is your y-intercept. Or where does this graph cross the y-axis? The y-intercept is probably the easiest to get because I made it easy. But the y-intercept is right here. It crosses the graph at this point right here. So what is the coordinates to that point? Well, that point is 0 on the x, like what we want, and y would be negative 1, 2, 3, 4, 5. So b is your y-intercept is going to be negative 5. So this value here is negative 5 on here. So that was pretty easy. And then to get slope, we can start at our y-intercept and go to another point that we know. It looks like I know this point pretty easily just by looking at the graph. So let's go to that point. And again, we're going to use slope as rise over run here. And we're going to go up 1, 2, 3, 4. So our rise is 4, and our run, we're going to go left 1. And this does have positive slope, so this is going to be a positive 4 over a positive 1, or your slope is just going to be positive 4. And once you have your m and your b, you just plug into your function. So f of x equals 4x plus negative 5, which, clean up your signs, you just get 4x minus 5. So given your line, you just find your slope. You can use it once you get 2 points that make sense on your graph, and you can get b by the y-intercept. So as long as you can find those two, you just plug into that to solve. If it gives you 2 points, because a lot of times it's going to give you points, like it'll give you this as 0, negative 5, and it might give you this point as that's in the same layer, 1, 5. It might give you those points. If it gives you those points, remember your slope can be found as well with y2 minus y1 over x2 minus x1, like you did yesterday. You can solve it this way as well. And when you look at it, let's see, y2, we'll call this y2, x2, x1, y1. Let's put it in that order, and you're going to get y2, which is negative 5 minus, why is this a negative 5? This is negative 1. It goes down 1. Minus negative 1 all over x2, which is 0 minus 1, gives you a negative 4 on top. You recall this comes out to be a plus 1. Negative 5 plus 1 is negative 4, and this becomes a negative 1 on the bottom, which reduces down to a positive 4, so you get the same slope. And then our y-intercept, we know that 0 equals negative 5 because it's on here. However, if it didn't give that to you, you could plug one of these points in to find your y-intercept as well, knowing that once you get your slope. So this here is the rule for our function. Pretty easy to come out. Again, where does it cross the y-intercept? And where does it, how's it rise and run going to the next point? What number would you put for y in the equation? You don't put a number, you put f of x. It's a function. This is saying a function of x. Here's x, there's a function of x. I mean, I guess you could call it a function of any letter you wanted, depending on what variable you use. Like if this was a g, then this would be a function of g, which you see sometimes. But in general, you do that. If you're going for your y-intercept here, if that's what you're asking, how would you get it using a point? You would plug in one of these points. So pick a point to use. Let's pick this one. You get negative 1 for your y, or your f of x, equals 4x, x is 1 in that case, plus b, and you can sit there and you can solve it, and you get 4 plus b equals negative 1, and you subtract 4, and you get negative 5, which is your y-intercept, equals b. Or you could have used another one. I mean, we could have used the other point too. Instead of plugging in negative 1 and 1, you could have plugged in 0 and negative 5. So 0 was here and negative 5 was here. That's your equal sign. 4 times 0 is 0 plus b equals negative 5. So, you know, that just goes away. Negative 5 equals b, you still get b. So this here is the function. The rule is the function. A function is a rule. What do I do to x to get to y? I multiply it by 4, then I subtract 5, and I get y. And that's coming from a graph. Any other questions about coming from a graph? Just pay attention, make sure your slope makes sense. This is positive slope, it's a positive 4, so this line does look like it's going in the positive slope direction. If it was going like this, it would be negative. And again, if it was going horizontally, it would be 0. Vertically, it's not going to happen. Can we start over? You can rewind and watch it. I will do another graphing one when I'm all done. So let's go on to doing it from a table, then we'll do it from a word problem, then I'll go back and do a graphing one. So again, let's going to delete most of that. Again, what we're going to do is we are going to be writing functions based off of graphs, tables, and word problems. My horrible handwriting. All right, so we're writing functions. We just looked at graphs. Let's look at tables now, okay? Tables, let's see if I can pull up a table here. Let's look at this table here. The table is going to be an XY table, and occasionally when it comes to functions, you're going to see it as an f and f of x for y, because again, y and f of x are the same thing. So here we're going to do, let's see, -1 goes to -2, 0 goes to 0, 1 goes to 2, and 2 goes to 4. With this table, it actually gives you 4 points. This actually gives you 4 points. For a line, you only need 2, but this gives you 4. So it gives you more information. But let's look at some things in the table. And this isn't going to be true for every table, especially when you get into actually collecting data and stuff, because nothing is going to be perfect and come out nice in the real world. But in the mathematical world, it does. And you can see as this is going up, going from -1 to 0, going from 0 to 1, going from 1 to 2, you can see that I'm adding 1 each time. +1, +1, +1. The next number would be adding 1 more. All right. And then you're going to look at this side here, and you take, this is jumping up by factors of 2, right? You're adding 2, adding 2, adding 2. So you keep going with that. And you get your, what this is called is a common difference. So what all of these is a common difference. And that's going to come in play later on in life, but I'm bringing it up now. So here we're going to look at it as we did yesterday though, and we only really need 2 points. So you're going to pick 2 of them. It doesn't matter which 2 you pick. All these points are part of the line, so pick 2 of them, and we're going to find the slope for it. So we might as well just pick the first 2. So let's pick -1 and -2, and 0 and 0. And we'll say this is 0.1 and this is 0.2, and name our parts. So this would be x1, this would be y1, this would be x2, this would be y2. And we're going to go ahead and plug into our slope equation to get our slope. Remember, slope is equal to m. In this case, you're going to get, let's see, y2 is -2 minus y2 is 0 in this case, minus -2 all over x2, which is 0 minus -1, and you're going to get a +2 here and a +1 here. And you should note those are your common differences over here, right? The difference between what x is jumping by and what 2 is jumping by. You get a 1 on the x's and a 2 on the y's. So here your slope is 2, because 2 divided by 1 is 2. So our slope is 2. M equals 2. Once you have that, you know that it's going to fit into f of x equals 2x plus b. You need to solve b, so you're going to plug in an f of x and a 2x. And it doesn't matter which point you pick, you will get the right one for your y-intercept. Or it actually gives you your y-intercept here, because your y-intercept, if you recall, equals where x equals 0. So when x is 0, what is y? So where x equals 0, what is y? So here, your y-intercept is given to you right here as 0, because x is 0 here, y would be 0. But we can also plug it in to solve. And you can use any of these points, including that one. I mean, I don't know why you'd use that one, but you already know it's 0. If it gives it to you, you get it right away. So this function really is f of x equals 2x plus 0, but we don't put the plus 0 because it's the identity. But here, if you wanted to use another point to do it, you could just use the 1 and the 2. So 2 is y. So if I use this point here as opposed to that point there, just to give you some practice, 2 is y, that is 2 times x is going to be 1 plus b. Again, 2 times 1 is 2 plus b equals 2. Subtract 2, you get 0 equals b. So you're still getting the same y-intercept. And there's your rule from the table. So going through the table like such. And again, it's really just finding 2 points, finding the slope, plugging one of those points back into your mx plus b, and getting your b value. So yesterday you practiced getting slope a lot. Today, throwing in the b value. So that's how you do it with a table. Next we're going to do it with a word problem, and this is just going to come from practice and just kind of reading carefully to determine what's what. So actually we can have that part. Let's get rid of all of this. So for our word problem, let me see if I can find a word problem. I'm probably going to have to type it in here because I don't have one typed up. Let's see. This is Apollo Works local store. I might have one in the actual notes. I don't have my notes right now. This might be the one I use in the notes. Here's So there's our word problem, and we want to model this as a function. So what we can do is get in another layer so I can actually write things. And see, so we got Paulo works at a local store. Each week he earns $300 salary plus a 3% commission on his sales. And we're going to write this as a function. This is a great example of maybe writing something as f of s instead. So this is a function of his sales. So s equals his sales. So if I want to do it that way, I'm going to just come over here. I'm going to say sales equals s. And I'm going to write the function f of s for a function of his sales. Yeah, it's really not difficult. I mean, this one here is going to be harder than those ones. But yeah, you're going to come up with the rules, but then you're going to write the rule as a function. So I want to see it written as like f of x equals something. I want the function. So here we got Paulo works at a local store. Each week he earns a $300 salary plus a 3% commission on his sales. And I want to write this as a function of his sales. So we know it's going to equal f of s here because I'm using s for sales just to change things up. And we know it's, I mean, you're doing linear stuff. As of right now, I mean, you should be thinking, hey, this is probably going to fit mx plus b, just because we're doing linear, and that's the only function rule you know right now. Later on, it's going to be a little more tricky because you're going to have to think, hey, is this a linear function? Is this a quadratic function? Is this an exponential function? Is this a logarithmic function? Is this a power function? I mean, there's a ton of different types of functions out there. But the only one we're looking at right now is a linear, so you should be thinking something along these lines right now. But anyways, let's see if we can figure out how much he makes, because that's the question you probably want to answer. So if S equals the sales, f of x is going to equal how much he makes. So that's going to be his paycheck, how much he makes. So Paulo works at a local store. Each week he earns $300 salary plus a 3% commission on his sales. So you should be thinking that right away he's going to earn $300 no matter what he does, plus his commission on his sales. And his commission is 3%, so 3% of his sales. And we don't really use percentages. We use the decimal version, so we're going to turn that to 0.03. And it's going to be 0.03 times however many sales he makes. So that's where your S is going to come in. Let me put that in parentheses. It might look a little nicer, right? And this here is your function. This is what your function is going to be. So f of S is equal to 300 plus the 3% of his sales. So 3% times his sales plus the 300 he makes equals how much he's getting paid. So it does come with a little reasoning, but that's your function right there. You might want to rewrite it so it looks more like this. In that case, it would be f of S equals 0.03, which is your m value. This here is your slope. Plus, I'm sorry, times S, which is your input, plus 300, which this here is your y-intercept. So you kind of pull it right out of there. Some are easier to do than others. Some you don't have much of a slope. And again, if this changes, like, hey, if this percent changes to 4%, then all that you're doing is changing this number here to 4. Right? So it does model it well, and the function is nice to have, so now you can tell anyone you want. Yeah, can we do a table again? Yeah, sure. We can do another table one. So we talked about each of them. Let's look at another table. It depends on what you choose for your variable, right? If you chose x as your variable, which we mostly do, then it's going to be f of x. If you chose g as your variable, then it would be f of g. If you chose c as your variable, then it would be f of c. It's really your choice. I mean, you're more than welcome to keep everything f of x. It's just that in life, you're going to see that, and I want you to know what it means. It just means your variable you're using is c instead of x. So it doesn't really matter. But yeah, we can do another table problem for John here. Let's delete everything. And let's just get a table going. So we got x, and I mean here I can use different variables. I can use s. Well, we just used s. I can use q. And over here is f of q. It doesn't really matter. It's really your choice, however you want to define it. And let's look at another table. I don't know, just moving on my examples here. We got -3 and 6, 0 and 0, 3 and -6, 6 and -12. Right away, it gives you an x equals 0, so I know right away my y-intercept here is the y value of this, which is 0. So my y value is going to be 0 there, or my y-intercept value is going to be 0. That's what my b equals. I mean, I can pull that out easily. And I honestly, yeah, each of the 4 or each of the 3 that you're doing today is going to have a 0 value. You can pull it right out of the table. So just looking at it, you should be able to tell me your y-intercept. To get your slope, though, slope or your m value, remember that is y2 minus y1 over x2 minus x1. So over here we're going to take any 2 points you want. It does not matter. Let's take this point and this point. Okay, let's call this point 1, and let's call this point 2, and that way this would be x1, this would be y1, this would be x2, this would be y2. And again, you could have picked any points you wanted there. As long as you know it's part of the line. So you had 4 options, pick 2 of them. Plug it into this, and you're going to get y2. y2 was that negative 12 minus y1 was this positive 6 all over x2, which was a positive 6, minus x1, which was a negative 3. Just watch your signs. This cleans up to be positive. So here you're going to have negative slope because one of these numbers will be negative, one will be positive, right? Negative 12 minus 6, signs are the same, so add and keep the sign. So that's going to be a negative 18. And over here, 6 plus 3 gives you a positive 9. And this reduces. You can reduce this down. 18 divided by 9 actually works, and this gives you a negative 2, right? So your slope here is negative 2. Your y-intercept is 0. So you have f of q, because that's what we decided to call it, equals negative 2 times q plus 0, which you don't need to put on because it's your identity. And you're left with that. Are there any other questions? But yeah, it should be working on 1 through 8. So page 420, 1 through 8. Tomorrow we're going to look at some scatter plot stuff. And we're going to look at how you can do what we just did here in Google Sheets. So